Hello everyone, welcome to my class. And in today's class, we are going to study the chapter 1 real numbers, which is intended for CBSE grade 10. Okay, so this class is going to be in accordance with NCERT latest syllabus 2024-25. Okay, let's start the chapter real numbers. And we are going to start with fundamental theory of arithmetic. So let's see what is fundamental theory of arithmetic. Fundamental theory of arithmetic states that every composite number can be expressed as product of primes and the factorization is unique and except for the order in which prime factor occurs. So what does it mean? See, whatever number you take, always the numbers can be expressed as the product of prime factors and their factorization will be unique. Means that whatever is the factorization of one number will not be similar to some other number. Every number will have one unique factorization. Okay, only we can say that we can change the order of prime factors, how they occur. Suppose, let's take this example 5005. Okay, so I will show you the prime factorization of 5005. Okay, so if you remember, any number which have 5 and 0 at the ones place is always divisible by 5. So we will start dividing this by 5. So you get 1001. Okay, now this is not divisible by 2, not by 3, not by 4, 5, 6. Let's check with 7. 717, 3, 7, 4. Yeah, this is divisible by 7. 717, and then 7 4 is 28, and 7 3 is 21. Yeah. Now, okay, now this is divisible by 11. So 11 ones 11, 13, and then now this is divisible by 13. Okay, now we got 5005. We can write this as 5 times 7 times 11 times 13. Okay, so this is the prime factorization of 5005. Now let's see one more number. So your next number is 342. So let's do prime factorization of 342. And you know that when you have 24680 at the ones place, that is an even number and it is always divisible by 2. So let's start with 2 and we have 171, and now this is divisible by 3, and again this is divisible by 3. Always start with the smallest prime number, whatever can divide the particular number. Okay, so be careful about that. Now we can write prime factorization of 342 as 2 times 3 times 3 times 19, which is nothing but 2 times 3 square times 19. I hope this is clear to everyone. Yeah, so you can write this in any order. Order doesn't matter, only you have to remember that according to fundamental theory of arithmetic, the prime factorization of any number is unique, irrespective of its order. Now, let's go to the next one. Okay, I hope you are well aware what is difference between a prime number and composite number. So prime number will have only two factors. So this is very important to remember. Prime number has only two factors. Only two factors. And a composite number means which is not a prime will have composite numbers will have more than two factors. Now, do you know why one is not a prime number? Because one has got only one factor, that is the number itself. That's why. And prime number should have two factors, only two factors, and one doesn't have two factors. It has got only one factor, so it doesn't satisfy the criteria of prime number. Okay, now let's do this question. Explain why 7 times 11 times 13 plus 2 times 11 is not a prime number. Okay, so this question says that this is not a prime number. So what we need to look for? We have to see that this number has got more than two factors. Now to work on it, let's simplify this. 7 times 11 times 13 plus 2 times 11. So this will be 7 times 11 times 13, that will give us 1001 plus 22, which will give you 1023. Okay, now we have simplified the number and we got this. Now we have to prove that this is not a prime number. To prove that this is not a prime number, we should prove that 1023 has got more than two factors. Let's do next 11 times 3 1, yeah, and then it will be 31 times. So 1023 has got factors 3 times 11 times 31. So it doesn't stand true on our criteria of prime number. Prime number must have only two factors, whereas 1023 has got three factors. So this is not a prime number. So we can write this answer as 1023, which is nothing but 7 times 11 times 13 plus 2 times 11 is not a prime number, since it has more than two factors. More than two factors, whereas a prime number must have only two factors. So you have to elaborate your answer properly, giving the proper reason. Yeah. So we are done with this question. Let's move to the next question. Check whether 4 to the power of n, where n is a natural number, can end with the digit 0 for any natural number n. So we have to prove that 4 to the power of n, okay, where n is a natural number, can end with digit 0. So for any number, to end with with the digit 0, or you can say that, okay, so for any number that it should have 0 at the end, we must have two factors. So let me show you. For any number to end with the digit 0, it must have two factors. Two factors. That is, this is important. This reasoning is important. Factors, that is 2 and 5. So if you have to prove that any number raised to the power of n is ending with 0, then you have to show that that number has 2 and 5 as one of the factors. Okay, now let's check what it shows us now. 4 to the power of n. Okay, 4 to the power of n can be factorized as 4 is nothing but 2 times 2, and this is whole raised to the power of n, and now I will write it as 2 this is 2 squared, 2 squared to the power of n, which will be nothing but 2 to the power of 2n. Okay, now we see that we have done the prime factorization of 4, and we could not see that 5 is existing anywhere. Okay, so you can write like prime factorization of 4 to the power of n does not contain 5. So, and as per the fundamental theory of arithmetic, we cannot have any other numbers which are the factors of 4 here, or 4 to the power of n. So this is the only factors which exist for 4 to the power of n. So we can say that there is no natural number n for which no natural number for which 4 to the power of n ends with 0. I hope this is easy to understand for everyone. Okay. Now let's see what's there in the next part of this. Now you have application of fundamental theory of arithmetic. So first we are going to study HCF and LCM by prime factorization method. So this is one very important concept because it comes as 1 or 2 marker in your exam and also asked in MCQs. So HCF of two or more numbers is the product of the smallest power of each common prime factor. So this you have to remember. HCF of two or more number is the product of the smallest power. This is important. Smallest power of each common prime factor. Then HCF of given number is 1. Okay. Now find HCF of 90, 144 by prime factorization. Okay, so we can do this. So what will be the HCF of 90? Prime factors of 90. Okay, we will do here prime factorization of 90 first. So this will be 2 times 45, then 3 times 15, then 3 times 5, and then 5 times 1. So we will write it here 2 times 3 times 3 times 5, which is 2 times 3 squared times 5. And now we will do for 144, 144, and that will give you, so we can write this as 2 times 2 times 2 times 2 times 3 times 3. So we can write it as now 2 to the power of 4 times 3 squared. Okay, now as per the definition, HCF of two or more numbers is the product of the smallest power of each common prime factor. Okay, so let's write here what are the common prime factors here. So the common prime factors are 2 and 3. See, 2 is in 90 also and 3 is in 90, but 5 is not there in 144 and 90 both. It is just only in 90, so we can leave it. This is not a common factor. So I will write common factor 2 and 3. And now what is the power? That is exponent. Exponent of 2. We will look for the smallest power. So if you look at 90, the smallest power of 2 is 1, and here also like it is 4. So we have to choose the smallest one. So I will go with 1 here. And here the smallest power of 3. Here power of 3 is 2 and here power of 3 is 2, so it is same, so we can write it this. So HCF will be 2 times 3 squared, that is 18. I hope this is clear to everyone. Now we will look how to do the LCM. Now, LCM of two or more numbers is the product of the greatest power of each prime factor involved in the numbers. So you can see that what it says, LCM of two or more numbers is the product of the greatest power of each prime factor. So we have to consider each prime factor and then we have to consider greatest power. So let's see how to work on the same numbers 90 and 144. So 90 we have done here already, so we can pick the factors. So 90 is 2 times 3 squared times 5, and 144 is 2 to the power of 4 times 3 squared. So let's work on the LCM. So you can see here, all the here we don't have to look for common factors, you have to look for all the prime factors. So your prime factors are 2, 3 and 5, and we will write the greatest power, that is the greatest exponent. So 2, here 2 is power 1 and here 2's exponent is 4, so we will go for 4. Then for 3 it is 2 here, 2 here, so we will write here 2, and 5 the power is 1. So your LCM will be, LCM is equal to 2 to the power of 4 times 3 squared times 5. So when we multiply them all together, we get 720. So I hope this is clear. It's easier. Yeah. Now find the HCF and LCM of 26, 65, and 117 using prime factorization method. And this question has come in 2023. So let's work on this. So your numbers are 26, 65, and 117. So we will write prime factors of 26. So this is easy, like we know it already. That is 2 times 13. 13 twos are 26. So 2 times 13. And then for 65, you can work on it. But this is also very simple. It is nothing but 13 times. Uh, so you can write it this way. So this is 13 times 5, and 117, if you remember all the table, it is nothing but 13 nines is 117, and in the prime factor form when we have to write, so we will write it this way. So you will write 3 times 3 times 13. Now what will be the HCF? We have to find HCF and LCM both. So HCF is smallest power of prime factors. So what are the smallest power of common factors? So what are the common factors? You have common factors which is in all three of them. One is 13. I don't find anything else. Yeah, so the common factor is just 13, and 13 has got the power 1. So in all of these three, so this is HCF is only 13. And then LCM is each prime factor and the greatest power we have to see. So we have one prime factor, that is 2. So let's write 2 here, and then we can write the next one as 13, and 13 has got the largest power 1. Let's write that. And then you have 5, write 5, and then you have 3 squared. So we can write this 3 squared as well. So so when you multiply this, 2 5s 10, 10 9s 90, and 90 times 13 will give you, okay, so 19 times 13, you can multiply and check it. It will give you 1170. So I hope this is clear. So HCF is 13 and LCM is 1170. So I hope this is clear to everyone. There should be no doubt in this question. Okay. Now you have the next topic, next question. The positive integers a and b can be written as a equals x cube y square and b equals xy cube. If x and y are the prime numbers, then find the LCM of AB. So this has come in 2019 question paper. So let's write this. A equals x cubed y squared and B equals x y cubed. So we have to find the LCM of AB. Now I can write the factors of A in this way. This is x times x times x times y, and then B equals x times y times y times y. Your question is to find LCM of A and B. And when we are finding the LCM, we consider all the prime factors and the largest power. So we are going to write x cubed times y cubed, because here x is cubed and here y is cubed, so that is the largest factor. So our LCM of AB is x cubed y cubed. I hope this is clear to everyone. Let's move to the next question. Next topic. So here you have relation between numbers and their HCF and LCM. For any two positive integers p and q, the relation between the numbers and their HCF and LCM is, so suppose your numbers are p and q, then HCF of pq times LCM of pq is equal to the product of p and q. Okay, so this is the relation. HCF of any numbers times LCM of any number is equal to product of the numbers. So in simple way you can remember it like this, product of the numbers. Now from this formula even you can find the HCF if you have the product of the numbers. So HCF of two numbers will be product of the numbers upon LCM of the numbers. Or you can also find the LCM of numbers. LCM of numbers p and q is nothing but the product of numbers upon HCF of the numbers p and q. So we will solve your question based on this relation of HCF and LCM and the product of numbers. Now your question is, if the HCF of 150 and 100 is 50. So this is given. Let's make a note of 150 and 100 is 50. Then find the LCM of 150 and 100. So be very, very clear about it when they have given, when the question says if the HCF of 150 and 100 is 50. So your question is presented in the way of like in the form of this, like HCF of two numbers, and then you have to find LCM. So if you are going to do prime factorization for LCM, then it is going to be wrong. You are not going to get marks for that. You have to work with the rule, that is HCF times LCM of two numbers is equal to product of the numbers. So following this, we have HCF of 150 and 100 times LCM of 150 and 100 equals product of the numbers. So my numbers are 150 and 100. So I will write 150 over times 100. Now what we can do is HCF of 150 and 100 is already given to us. So that is 50, and we have to find the LCM of 150 and 100, which is nothing but 15,000, and then you get your LCM of 150 and 100 as 15,000 over 50. So this will give you 300. So your LCM of 150 and 100 is 300. Okay, so I guess this is easy. Okay. Now we have the next question. If the LCM of 26 and 91 is 182, then find their HCF. Definitely you are going to use the formula HCF of 26 and 91 times LCM of 26 and 91. Okay, so you have the product of the numbers, that is 26 times 91. Now, so LCM is already given. we can replace it here. So LCM of 26 and 91 is 182. And this is 26 times 91. Hence, your HCF of 26 and 91 is 26 times 91 over 182. So, you will get here HCF of 26 and 91. We can solve it. 2 nines, 2 ones, and 13. And then 91, 91 cancel, and then you get 13. This is the answer, and you are done. Easy. Let's move to the next question. So, this question has appeared in question paper 2024, the recent one. Your question is, given HCF 2520 and 6600 is equal to 40. So HCF of 2520 and 6600 is 40. And the LCM is also given. LCM is 252 times K. So the numbers are given, the HCF is given, and LCM is given. Now you have to find the value of K. So let's do this. So again, we have same rule. HCF of 2520 sorry, this has to be comma 6600 times LCM of 2520 comma 6600 equals the product of the numbers, that is 2520 times 6600. We substitute the values. Now HCF is 40, LCM is 252 times K is equal to 2520 times 6600. We work on it. So you get K is equal to 2000. Oh, this is okay, right. 2520 times 6600 over 40 times 252. Yeah, this is simple. 10, and then we have here 4, and then we can divide this as well. Okay, so you have this 6000. No. This is 6,000. One moment. So I will write this properly. This is 6,600. Now we can divide it. So 4 ones 4, 4 ones 4, 4 6 24, 4 5 20, and 0. So the value of K is 1650. Easy? Yeah. I hope this is clear to everyone. Okay. Now let's go to the next part. HCF of two numbers is 27 and their LCM is 162. Okay, so HCF of two numbers is HCF is 27, LCM is 162, and one number is 54. Then the other number is, so this question has already come in 2022. So we follow the rule. HCF of the numbers times LCM of the numbers is the product of the numbers. So we write here now, this is 27 times 162, and here, so if one number and this, okay, let me write it this way, 54 times another number. Okay, so this is what you have to find. So it will be like this, another number is equal to, or other number is equal to 27 times 162 over 54. Now, when we calculate this, okay, so cancel, you get here 2 and then you get here 81. So your other number is other number is 81. Yeah, so we did so many question on one concept. Yeah, let's see what's there in the next part. Yeah, this is one good question. Assertion: the number 5 to the power of n cannot end with the digit 0 where n is a natural number. And the reason given is prime factorization of 5 has only two factors, 1 and 5. Oh yes, 5 to the power of n cannot end with digit 0. Why? Because for a number to end with digit 0, it must have the factors 2 and 5. So, you see, the factors of 5 are only 1 and 5. So, what this sentence, the assertion, the number 5 to the power of n cannot end with the digit 0, where n is a natural number, is true. This is true. And they have given the reason here. Prime factorization of 5 has only two factors, 1 and 5. Yeah, we cannot see 2 anywhere. So, for a number to end with this is 0, they should have a factor as 2 and 5. The two factors are must, 2 and 5, but we don't get 2 here. We just have 5. So this is also true. So assertion is true and the reason is also true. So which one will be there? Both assertion and reason are correct, and reason is the correct explanation. Yeah, yeah. So this, so your answer is A part. Now let's see what is another one. The HCF of two numbers is 5. So here it mentions that HCF of two numbers is 5 and their product is 150. Then their LCM is 40. Let's check the assertion first. Now we know the rule, HCF time LCM is equal to product of numbers. So we have the LCM, HCF 5 and LCM is given. Okay, we will find out LCM and we will see whether this is correct or not. So LCM is equal to product of the numbers is 150, and then when I'm solving this I get LCM is equal to 150 over 5, that is 30. So you can see here the LCM is 30, and in assertion it is given that their LCM is 40. So definitely our assertion is not correct. Assertion is false. Now let's see the reason. For any two positive integers a and b, HCF of ab times LCM of ab is equal to product of a and b. This is correct, and this question has come in the sample paper. Okay, so the reason is correct, but assertion is wrong. Yeah, so assertion is incorrect and the reason is correct. So where we find that assertion is incorrect and reason is correct, so D is your answer. So this is the answer. Assertion is incorrect but reason is correct. Yeah, let's move to the next one. And here, assertion root 2 times 5 minus root 2 is an irrational number. So, here it says that root 2 times 5 minus root 2 is an irrational number. See, when you subtract a rational and irrational number, you definitely get a irrational number. And here root 2 is irrational. So, this is irrational number. Now, we see that this is correct. Whatever is the assertion, this is true. Our assertion is true. But the reason is given, product of two irrational number is always irrational. See, this has come in cbse 2024 basic paper. Now let's take one example of root 3 times root 3. Root 3 is an irrational number and root 3 is an irrational number. And when I find the product of root 3 and root 3, I get answer as 3, which is a rational number. So the reason product of two irrational number is always irrational is false, right? So this is not correct. So assertion is true and the reason is assertion is correct and the reason is incorrect. So C stands true here. So C is your option. We can write this as the answer. Now let's move to the next question. So here Ramya has 143 stamps. She gives away 11 stamps and divides the remaining equally into groups. Amit has 220 stamps. He gives away 11 stamps and divides equally into groups. They end up with same number of groups. Based on the above information, answer the following question. What is the number of groups? So, first you understand this question, and this is competency based question. So now, like for cbse exams, your pattern is changing to competency based questions, so you need to practice a lot competency based questions. Now you look here, Ramya has 143 stamps. Okay, first we understand the whole thing. She has got 143 stamps and she gives away 11. So how many stamps she is left with? 143 minus 11, that will give you 132. And then Amit has 220 stamps and he gives away 11. So he is left with 209 stamps. So this is for Amit. Now your question is, he gives 11 steps and divides equally into groups. You have to find the number of groups. Whenever you have a question of finding the number of groups or dividing into how many parts, like that, always you need to find the HCF. So I hope this is clear. So you can find HCF of what are the number of stamps left. So it is 132 and 209. So you need to find the HCF of 132 and 209. So yeah, we will do prime factorization. 132. So 11 times this, and yeah, 11 times 12 I'm getting here. And then when we divide this one, 209, so you will get here again 11 ones 11 and 11 nines. So yeah, so this is 11 times 12 and this is 11 times 19. So our HCF is 11. So what is the number of groups? So your number of groups will be, number of groups will be 11. Now the next part is, what is the number of stamps in Amit group? It means that in each group how many stamps Amit is going to have. Okay, so we can calculate this. For Amit it will be, Amit has got 209 and he is dividing them into 11 groups. His 209 stamps can be put into 11 groups. Therefore, the number of stamps in each group, Amit has stamps in each group is equal to 209 divided by 11, and that will give you 19. So Amit will have 19 stamps in each group. If your question is about Ramya's, how many stamps she has in each group, you can divide 132 by 11 and you will get 12. Yeah, so I hope this is clear. This was one question of based on HCF. Now let's see what is the next question. Yeah, the next question is, the traffic lights at three different roads Crossings change after every 48 seconds, 72 seconds, and 108 seconds, respectively. If they change simultaneously at 7 a.m., what time at what time will they change the color together next? Okay, so this question is about an event to happen at the same time. So whenever you are looking for an event to occur at the same time, we have to find the LCM. So events to occur at same time, you must find LCM. So now we will find LCM of 48, 72, and 108. So write the factors. Okay, so factors of 48 will be 2 times 4, 12, 4 is 48. Okay, right, yeah. So it will be 2 times 2 times 2 times 2, 2 to the 4, 4 to the 8, it to the 16 times 3. And then for 72, it will be 2 times 2 times 2 times 3 times and 3. So I will write it here 2 to the power of 4 times 3. I will write here 2 to the power of 3 times 3 squared. And then we have another one, 108. So which is nothing but 2 times 2 times 3 times 3 times 3, which is nothing but 2 squared and 3 cubed, right? So your LCM will be the largest product of the largest prime factors. So LCM is, we don't have any other prime factor other than 2 and 3. So just go with the largest power of 2 is 2 to the power of 4 and 3 is 3 cubed. That will give you uh, 2 times 2 is 4, 4, 4, 16, 16 times you have 27, and that will be equal to 432 second. Okay, now what is the question? If they change simultaneously at 7 a.m., so 7 a.m. they are changing the colors. Now at what time will they change together? You have to tell the time. So it will be, so we will divide 432 seconds by 60 to convert it into minutes. So 432 divided by 60. So you will get here, let me do it like this. 30, 2 to the 4, 2 to the 2. Then we can write it. So 216 divided by 30. So 37 is 210. And here we have 6. I hope this is clear to everyone. Yeah. So you can write this as, one moment, I think, one second. Let me divide it here itself. And then you have 15 here and you get 108 here. So we divide 108 by 15 and then you get, yeah, we get like this. So it will change after 7 minutes and 3 seconds. Yeah. So I hope this is clear to everyone. Yeah. So this is very important topic with respect to your exam, because this kind of question based on HCF and LCM, it keeps on coming. Yeah, so you need to practice many more questions based on this concept. So you also have a question when suppose like two sprinters are running, when they are going to meet at certain point, like that, or like what are the groups something can be divided into. Yeah. So now, okay, so in this part we have to write the timing. So since they are changing at 7 minutes 3 seconds, so your next time when they are going to change it 7, so it will be 7 a.m. 7 a.m. only, and 7 minutes 7. So I got 3 seconds. So I hope this is clear to everyone. Yeah. Now let's go to the next one. Yeah, so we are done with one part of the real numbers. That was fundamental theory of arithmetic, which also included HCF and LCM and their relation between the two numbers. Now, the second part of your chapter is irrational number. So simple. What are irrational numbers? The numbers which cannot be written in the form of P over Q, where P and Q are integers and Q is not equal to 0. So, example of irrational numbers are root 2, root 3, root 5. They are all irrational numbers. So, I hope you are well aware about the rational numbers. Rational numbers can be written in the form P over Q, where q is not equal to 0. So suppose if you have 3, 3 can be written as 3 over 1. So 3 is a rational number. You have root 16. Root 16 is nothing but 4, which can be written as 4 over 1. So this is also a rational number. But if you have root 17, root 19 like that, we cannot have a specific a whole number like this, and then this is your irrational number. Okay, so I hope the difference between irrational and rational number is clear. Now, so this is very very important. This type of question come in many forms. So your question is, prove that root 2 is an irrational number. Okay, so when we say that root 2 is an irrational number, so what are the things we have to consider? That it cannot be written, root 2 cannot be written in the form of P over Q or A over B, whatever you can say. Okay. Now, and we can say that when it is, we cannot write it in form of P over Q, then there are no common prime factors also, right? Okay. Now, to prove this question, we are going to use contradiction. Means we will assume that root 2 is a rational number. Okay. So let's see that. So if I say root 2 is rational number, it means we can write this in the form of P over Q or A over B. Let's say that we can write this in the form of A over B, where B is not equal to 0. So root 2 is equal to A over B, and this is a rational number. So remember that rational numbers are always co-primes, means they will not have anything as common factor. Always the co-prime numbers have a common factor as 1, so they will not have any common factors. So now A upon B, where A and B are co-prime. Yeah. Now see, we will square both the sides, so you will get root 2 whole square, which is a upon b. So we, as I said, we are going to prove this one by method of contradiction. Means we have to prove irrational, and contradictory method is that I'm going to assume it as rational. I will try to prove this as rational, and when I'm not able to prove this as rational, then we can conclude that this is irrational number. So let's see how we do it actually. Root 2, we will square it, and then both the side we will square. Hence you get 2 equals a square upon b square. Okay. Now you can say that we just cross multiply and we get the value of a square. And now you can also have now we yeah, now we will assume that let a is equal to m. Okay, now when a is equal to, one moment, we have to so before I complete this, I should introduce you to one theorem as well. That is very important. I missed to say that. So your theorem is that, okay, this is very important theorem. Let p be a prime number. Let me explain it here. Your theorem is, let p be a prime number, then a is a positive integer if p divides a square, then p divides a. This is very important. So what it says that, let p be a prime number and a is a positive integer. So if p divides a square, then p also divides a, right? So this is the theorem which we are going to use wherever you have to prove some number is irrational number. Okay. Now you see that we have assumed root 2 as rational number, and then we wrote root 2 is equal to a over b, and we square both the sides, and when we square both the sides we get 2 here. 2 is equal to a square upon b square. On cross multiplying we get a square is equal to 2b square. So it implies that 2 divides a square, right? Because 2 divides a square, therefore 2 also divides a. Right, this is very important point we have to consider. So this is from the previous theorem which I explained you just now. If p is a prime number and a is a positive integer, if p divides a square, then p also divides a. So here, um, 2 divides a square, therefore 2 also divides a. Okay, now we will see the next part of it, how to move with this thing. Now you can say that we can consider a is equal to 2m. Now we have a is equal to 2m, so we can write it as, see, also you have a square is equal to 2b square. So we can also have now 2m, because a is 2m, we have considered 2m whole squared is equal to 2b squared. So you will get here 4m square, which is equal to 2b square. And now when we solve it, you get a value of b square, that is b square is equal to 4m square upon 2, that will give you 2m square. So b square is 2m square. Now with our previous theorem, if 2 divides b square, see, 2 divides b square, therefore 2 divides b, 2 also divides b. See, now here you can see is 2 divides a and 2 divides b. It means that 2 is dividing A, 2 is dividing B, means 2 is common factor of A and B. Yeah, 2 is common factor of A and B. But this is contradictory, because we assumed A over B to be a rational number, right? And when it is a rational number, they could not have any common factor other than 1. So why this contradiction has arisen? This contradiction has arisen by considering root 2 as a rational number. So we can write here 2 is common factor of AB, which contradicts the fact that AB have no common factor, or you can say are co-primes, no common factors. So why this contradiction arises? So this contradiction arises by assuming root 2 as rational number. So you have to write all these point in exam, and hence root 2 is irrational number. I hope this is clear to everyone. So let me complete my sentence. So we can say that hence root 2 is an irrational number. Simple. We will see few more question on this. So your next question is, you can get an exam, prove that root 3 is an irrational number, prove that root 5 is an irrational number, root 7 is an, so you need to practice, and everything will have the same concept. Assume them to be a rational number, and then show that they have some common factor among them, and then you can say like this is contradictory, and then hence it is an irrational number. Now, your next question is, prove that 3 root 2 is an irrational number. So, again, we are going to prove it by contradiction only. So, let's assume 3 root 2 is a rational number, right? If this is a rational number, then we can write 3 root 2 is equal to P over Q. Yeah. And now, okay, so let's see. Now we will write it this way. We can write root 2 equals P over 3Q, right? Now, see, the P is an integer and 3 upon Q, 3Q is also an integer. So where 3Q is not equal to 0, right? Because we are assuming them to be a rational number. Okay, now, so if we have assumed p over 3 root 2, which is equal to p over q, as a rational number, hence what happens now, p over 3q is rational number, so root 3 also has to be a rational number. Therefore root 3 is also a rational number. Sorry, this has to be root 2. Why did I write root 3? Yeah, root 2. Root 2 is also a rational number, right? But we already know that root 2 is an irrational number. So we already know root 2 is irrational number. So root 2 being an irrational number is contradictory to our assumption. So we can always say that our assumption is wrong. Hence 3 root 2 is an irrational number. I hope this is clear. This is easy to prove. So in this we don't have to do much. You just assume it this way. See, your question is, prove that 3 root 2 is a irrational number. So we will assume that 3 root 2 is a rational number. Because this is a rational number, so we can write it in the form of p over q. When we write it in the form of p over q, then you can move this 3 to the, you can transpose it, so you will get root 2 is equal to p upon 3q. Why we are doing it? Just to prove our assumption is wrong, and we already know that root 2 is an irrational number. So when we are equating it like this, root 2 is equal to p over 3q, that means see, p over 3q is a rational number because of our assumption. That will prove that root 2 is also a rational number, right? But we already know that because p upon 3q is a rational number, so root 2 is also a rational number. But we already know that fact root 2 is not a rational number. Root 2 is irrational number. Hence, our assumption is wrong. Hence, 3 root 2 is an irrational number. I hope this is easy to understand. Yeah. Now, let's see this question. And now this question is, prove that 3 minus 2 root 5 is an irrational number. Okay, so yeah, so what we can do is, again, we will assume it that way only. So let's assume that 3 minus 2 root 5 is rational number. And since this is a rational number, so 3 minus 2 root 5 is nothing but p over q. So we can have it this way. We just take this another side and you can have 3 minus p over q, which is 2 root 5. And then it might be given in the question that root 5 is irrational number, or if it is not given, you can say that this is the fact that root 5 is an irrational number. So we already know that this root 5 is irrational. Now we solve just this part. So this will be 3q minus p over q, which is nothing but 2 root 5. And then you just isolate this 5. So when we isolate this 5, it will be like this. 2 will come this side, so you have 3q minus p over 2q. Okay, now we know that root 5 is irrational number, and we have assumed here this as rational. So if they are equal, this cannot be irrational, right? This cannot be rational. This also has to be irrational. But we have assumed this as the rational number. Okay. Now, when this is 3q minus p upon 2q is a rational number, yeah, then we are assuming that root 5 is also a rational number. So this is not correct. So our assumption is wrong. So this show that if we accept this is a rational number, then since this is equal to root 5, we have to accept this is also a rational number. But we already know the fact that root 5 is irrational number, so it contradicts our assumption. Since root 5 is irrational number, this contradicts our assumption. Therefore, our assumption what was that number? 3 minus 2 root 5 is rational number is 3 minus 2 root 5 is irrational number is incorrect. Incorrect. Therefore, 3 minus 2 root 5 is an irrational number. I hope this is clear to everyone. So, so these are few questions which we did from the entire chapter, and this completes your real number chapter. And so stay tuned for many more videos on this chapter and another new chapters as well. I will come with few more competency based question of this chapter. Now I will sum up this question again. Prove that 3 minus 2 root 5 is an irrational number. In your question, they might give you root 5 is irrational, might not. Okay, then you have to assume that 3 minus 2 root 5 is a rational number, as we are proving this by method of contradiction. So that will give you 3 minus 2 root 5 is equal to p over q. See, our key factor is root 5 is irrational number, so we will isolate here root 5. So it will be 3 uh, 3 minus p over q, which is equal to 2 root 5. So you solve it, you get it here, 3q minus p over q, which is equal to 2 root 5. Now again I'm going to isolate root 5. So root 5 will be equal to 3q minus p over 2q, like this. Now this is your rational number, and we already know the fact that root 5 is an irrational number. They cannot be equal. So since root 5 is irrational number, so this contradicts our assumption that this is a rational number. So our assumption 3 minus 2 root 5 is irrational. This rational number is incorrect. One moment. Is rational number is incorrect. So is rational number is incorrect. So root 3 minus 2 root 5 is an irrational number. Okay, so I hope this is clear to everyone, and in the coming up videos I will come with more competency based question, and stay tuned for a few more chapters. Thank you for watching.